something we spend about a third of our lives doing.
It's something we spend about a third of our lives doing.
But do any of us really understand what it's all about?
But does anyone else understand what's all about? What's all about? But do any of us?
2,000 years ago, Galen, one of the most prominent medical researchers of the ancient world, proposed that while we were awake,
2,000 years ago, one of the most prominent medical researchers of the ancient world.
our brain's motive force,
Our brain's motive force.
its juice,
It's just motive force.
would flow out to all the other parts of the body,
Would flow out to all the other parts of the body,
animating them, believing the brain all dried up.
animating them, believing them, animating them, believing the brain all dried up.
And he thought that when we sleep, all this moisture that
And he thought when you sleep, all this moisture
filled the rest of the body would
that filled the rest of the body
come rushing back, rehydrating the brain
would come rushing back, dehydrating the brain
and refreshing the mind.
and refreshing the mind.
Now that sounds completely ridiculous to us
Now it sounds completely ridiculous to us.
now. But Galen was simply trying to explain something about sleep
But Galen was just simply trying to explain something about sleep
that we all deal with every day.
that we all deal with every day.
See, we all know based on our own experience that when
That we all know based on our experience.
you sleep, it clears your mind.
When we sleep, it clears your mind.
And when you don't sleep, it leaves your mind murky.
And when you don't sleep, it leaves your mind murky.
But while we know a great deal more about sleep now than
But what we know more about, but what we know a great deal more about sleep than now than
when Galen was around, we still haven't understood why it is that sleep, of all of our activities, has this incredible restorative function for the mind.
we still haven't understand why is the sleep of all our activities has incredible restorative function for the mind.
So today, I want to tell you about some recent research
So today I want to tell you about some recent research
that may shed new light on this question.
that may shed new light on this question. Shed new light on the question.
We found that sleep may actually be a kind of elegant design solution
We found that sleep may be a kind of elegant design solution
to some of the brain's most basic needs.
to some of the brain's most basic needs. 이거 엄마 진짜 못한다.
A unique way that the brain meets the high demands and the narrow margins that set
A unique way that the brain meets the high demands and narrows margins
it apart from all the other organs of the body.
that set it apart from all the other organs of the body.
So almost all the biology that we observe
So almost all the biologies we observe
can be thought of as a series of problems
can be thought of as a series of problems
and their corresponding solutions.
and their corresponding solutions.
And the first problem that every organ must solve
And the first problem that every organ must solve
is a continuous supply of nutrients to fuel all those cells in the body.
is continuous supply of nutrients to fuel all those cells of the body.
In the brain, that is especially critical.
In the brain, that is especially critical.
Its intense electrical activity uses
This intense selective what? Intense electrical activity
up a quarter of the body's entire energy supply.
uses up a quarter of the body's entire energy supply.
Even though the brain accounts for only about 2% of the body's mass.
Even though the brain counts only about 2% of the body's mass. Even though the brain accounts for only about 2% of the body mass.
So the circulatory system solves
So the circulatory system solves
the nutrient delivery problem by
the nutrient delivery problem
sending blood vessels to supply nutrients and oxygen to
to supply nutrients and oxygen.
every corner of our body.
왜 이렇게 안 움직이지 몸이?
You can actually see it in this video here.
You can actually see it in this video here.
Here we're imaging blood vessels in
There are images of blood vessels
the brain of a living mouse.
in the brain of a living mouse.
The blood vessels form a complex network that
The blood vessels form a complex network
fills the entire brain volume.
that fills the entire brain volume.
They start at the surface of the brain and then they dive down into the tissue itself.
They start at the surface of the brain and dive down into this tissue cell.
And as they spread out, they supply nutrients and oxygen
As they spread out, they supply nutrients and oxygen
to each and every cell in the brain.
to each and every cell in the brain. 왜?
아주 주옥 같은 글들이 많네.
누구?
아이들의 웬일이 있어요, 우리 다들.
정문? 정문?
아니
독후감?
독후감.
Now, just as every cell requires nutrients to fuel it,
Just as every cell requires nutrients to fuel it,
every cell also produces waste as
every cell also produces waste
the byproduct.
as a byproduct.
And the clearance of that waste is the second basic problem that each organ has to solve.
And the clearance of the waste is the second basic problem each organ has to solve.
This diagram shows the body's lymphatic system,
This diagram shows the body's lymphatic system,
which has evolved to meet this need.
which has evolved to meet this need.
It's the second parallel network of vessels that
It's the second parallel network of vessels
extends throughout the body.
that extend throughout the body.
It takes up proteins and other waste from the
It takes the proteins and other waste
spaces between the cells.
from the spaces between the cells.
It collects them and then dumps them into
It collects them and dumps them
the blood so they can be disposed of.
into the blood so they can be disposed of.
But if you look really closely at this diagram, you'll
But if you look closely at this diagram,
see something that doesn't make a lot of sense.
you see something that doesn't make a lot of sense.
So if we were to zoom into this guy's head,
So if you were to zoom into this guy's head,
one of the things that you would see there
one of the things you see there
is that there are no lymphatic vessels in the brain.
is that there are no lymphatic muscles in the brain.
But that doesn't make a lot of sense, does it?
But that doesn't make a lot of sense, does it?
I mean, the brain is this intensely active organ
But the brain is this intensively active organ
that produces a correspondingly large amount of waste
that produces correspondingly a large amount of waste
must be efficiently cleared.
that must be efficiently cleared.
And yet, it lacks lymphatic vessels,
And yet it lacks the lymphatic muscle vessels,
which means that the approach that the rest of the body takes to clearing away its waste
which means that the approach that the rest of the body takes to clearing away its waste
won't work in the brain.
won't work in the brain.
So how then does the brain solve its waste clearance problem?
So then, how does the brain solve its waste clearance problem?
Well, that seemingly mundane question
That seemingly mundane question
is where our group first jumped into the story.
is where I first jumped into the story.
And what we found as we dove down into the brain
And what we found as we dove down into the brain,
down among the neurons and the blood vessels,
down among the neurons and blood vessels,
was that the brain's solution to the problem of waste clearance,
was that the brain's solution to the problem of waste clearance,
it was really unexpected.
it was really unexpected.
It was ingenious,
It was ingenious,
but it was also beautiful.
but it was also beautiful.
Let me tell you about what we found.
Let me tell you about what we found.
So the brain has this large pool of clean, clear fluid
The brain has this large pool of clean and clear fluid
called cerebral spinal fluid.
called the cerebral spinal fluid. Cerebral spinal fluid.
We call it the CSF.
We call this CSF.
The CSF fills the space that surrounds the brain,
The CFS fills the space that surrounds the brain,
and waste from inside the brain make their way out to the CSF.
and the waste tip inside the brain makes its way out to the CSF,
Which gets dumped.
which gets dumped. 괜찮아 이게.
엄마께 저번에 은일이 어떤 칼이랑 가위랑 펜이랑 자랑 같이 있었던 그 펜 있잖아요. 그거 어딨어요?
Along with the waste into the blood.
Along with the waste into the blood.
So in that way it sounds a lot like the lymphatic system, doesn't it?
So now it sounds a lot like our lymphatic system, doesn't it?
But what's interesting is that the fluid and the waste from inside the brain
What's interesting is that the fluid and the waste inside the brain,
they don't just percolate their way randomly out to these pools of CSF.
they don't just percolate. Slowly through a substance with very small percolate. They don't just percolate their way randomly out to those pools of CSF.
Instead, there is a specialized network of plumbing
Instead, there is a specialized network of plumbing
that organizes and facilitates this process.
that organizes and facilitates this process.
You can see that in these videos.
You can see that in this video.
Here, we're again imaging into the brain of living mice.
Here again, we're again imaging into the brain of a living mice.
The frame on your left shows what's happening at the brain's surface, and
The picture on the left shows what's happening at the brain surface.
the frame on your right shows what's happening down below the surface of the brain within the tissue itself.
The right slide shows what's happening down below the surface of the brain within the tissue cell.
We've labeled the blood vessels in red,
I labeled the blood vessels in red.
and the CSF that's surrounding the brain will be in green.
The CFS surrounding the brain will be in green.
Now, what was surprising to us
Well, now what was surprising to us
was that the fluid on the outside of the brain,
was that the fluid on the outside of the brain,
it didn't stay on the outside.
it didn't stay on the other side.
Instead, the CSF was pumped back into and through the brain
Instead, the CF was pumped back through the brain
along the outsides of the blood vessels.
along the outside of the blood vessels.
And as it flushed down into the brain along the outsides of these vessels,
And as it flushed down into the brain along the outside of these vessels,
it was actually helping to clear away, to
it was actually helping to clear away,
clean the waste from the spaces between the brain cells.
to clean the waste from the spaces between the brain cells.
If you think about it, using the outsides of these blood vessels like this,
If you think about it, using the outside of these blood vessels like this
is a really clever design solution.
is a really clever design solution.
Because The brain is enclosed in a rigid skull.
The brain is enclosed in a rigid skull,
음악 없는데?
And it's packed full of cells, so there is no extra space inside it.
그거지.
and packed full of cells, so there's an extra space inside it
For a whole second set of vessels like the lymphatic system.
for a whole second set of vessels like lymphatic system.
Yet the blood vessels, they extend from the surface of the brain
Yet the blood vessels, they extend from the surface of the brain
down to reach every single cell in the brain.
down to reach every single cell in the brain,
Which means that fluid that's traveling along the outsides of these vessels
which means that the fluid that's traveling along the outside of these blood vessels
can gain easy access to the entire brain's volume.
can get access to the entire brain's volume.
So it's actually this really clever way
So it's actually this really clever way
to repurpose one set of vessels,
to repurpose one set of vessels,
the blood vessels,
the blood vessels,
to take over and replace the function of a second set of vessels.
to replace and take over the function of a second set of vessels,
The lymphatic vessels.
the lymphatic
To make it
vessels,
so you don't need them.
to make it so you don't need them.
And what's amazing is that no other organ takes quite this approach
And what's amazing is that no other woman, no other organ takes quite this approach
to clearing away the waste from between its cells.
to clearing the waste between the cells.
This is a solution that is entirely unique to the brain.
That is a solution that is entirely unique to the brain. Oh.
But our most surprising finding
But our most surprising finding
was that all of this,
was that all of this,
everything I just told you about,
everything I just told you
with
about,
all this fluid rushing through the brain,
with all this fluid rushing through the brain,
it's only happening in the sleeping brain.
it's only happening in the sleeping brain.
Here, the video on the left shows
Here, the video on the left shows
how much of the CSF is moving through the brain
how much of the CSF is moving through the brain
of a living mouse while it's awake.
of a living mouse while it's awake.
It's almost nothing.
It's almost nothing.
Yet in the same animal, if
What? Yet in the same animal,
we wait just a little while
if we wait just a little while
until it's gone to sleep,
until it's gone to sleep,
what we see is that the CSF
what we see is that the CSF
is rushing through the brain.
is rushing through the brain.
And we discovered that at the same time, when the brain goes to sleep,
And we discovered that at the same time when the brain goes to sleep,
the brain cells themselves seem
the what? The brain cells themselves
to shrink, opening up spaces in between them,
opening up spaces in between them,
allowing fluid to rush through and
allowing fluid to rush through,
allowing waste to be cleared out.
allowing waste to be cleared out.
So it seems that Galen may actually have been sort of on the right track when he wrote about
So it seems that Gain was actually right on the track when he wrote about fluid.
fluid rushing through the brain when sleep came on. Our own research, now it's 2,000 years later, suggests that what's happening is that when the brain is awake and
What happens is that when the brain is awake,
is at its most busy, it puts off
when it's most busy,
clearing away the waste from the spaces between its cells until later. And then when it goes to sleep and has
oh. Now it's 2,000 years later, suggests that what's happening is that when the brain is awake and at its most busy, it puts off clearing away the waste from the space between cells until later. And then when it goes to sleep and it doesn't have to be as busy,
doesn't have to be as busy. It shifts into a kind of cleaning mode to clear away the waste
What?
from the spaces between its brain. The waste that's accumulated through.
아 진짜. shifts into a kind of cleaning mode to clear away the waste from the space between cells. Was the waste that accumulated throughout the day.
throughout the day. So it's actually a little bit like how you or I,
So it's actually like how you and I
we put off our household chores during the work week
how to put off household chores during the work week
when we don't have time to get to it. And
when we don't have time to get to it.
then we play catch up on all the cleaning that we have to do.
And we play catch up we play catch up on all the cleaning we have to do
When the weekend rolls around.
when the weekends rolls around.
Now, I've just talked a lot about waste clearance,
And I just talked about a lot about waste clearance,
but I haven't been very specific about the kinds of waste that the
but I haven't been very specific about the kinds of waste
brain needs to be clearing
that the brain needs to be clearing
during sleep in order to stay healthy.
during sleep. What? In order to stay healthy.
The waste product that these recent studies focus most on is
The waste product that this recent studies focus most on
amyloid beta,
is amyloid beta,
which is a protein that's made in the brain all the time.
which is a protein that is made in the brain all the time.
My brain's making amyloid beta right now, and so
My brain's making amyloid beta right now,
is yours.
so is yours.
But in patients with Alzheimer's disease,
But in patients with Alzheimer's disease, 괜찮다니까, 아들아?
아, 네. 저 그 어디 거기
amyloid beta builds up and aggregates in the spaces between the brain cells instead of being cleared away like a
Amyloid builds up and aggregates in the space between the brain cells instead of being
it's supposed to be.
cleared away like it's supposed to be.
And it's this buildup of amyloid beta that's thought to be one of the key steps in the development of that terrible
Build up antibody that will help in develop that
disease.
Alzheimer's disease.
So we measured how fast
So we measure how fast
amyloid beta is cleared from the brain when it's
amyloid beta. Have you heard about amyloid beta? 이제?
아멜로이드 베타.
아, 이게 알츠하이머病구나.
그거.
awake versus when it's asleep. And we found that indeed the clearance of amyloid beta
이런 색깔.
The clearance of amyloid beta
is much more rapid from the sleeping brain.
much more rapid from the sleeping brain.
So if sleep then is part of the brain's solution to the
So if sleep then is part of the solution to
problem of waste clearance,
the problem with clearance,
then this may dramatically change how we think about the relationship between sleep, amyloid beta, and Alzheimer's disease.
and this may dramatically change how we think about the relation between sleep, amyloid beta, and Alzheimer's disease.
A series of recent clinical studies
A series of recent clinical studies
suggest that among patients
suggested among patients
who haven't yet developed Alzheimer's disease,
who haven't yet developed the Alzheimer's disease,
worsening sleep quality and sleep duration
worsening sleep quality and sleep duration
are associated with a greater amount of amyloid beta building up in the brain.
is associated with a greater amount of amyloid beta accumulating in the brain.
And while it's important to point out that these studies don't
While it's important to point out these studies don't
prove that lack of sleep or poor sleep cause Alzheimer's disease,
the lack of sleep will poor sleep cause Alzheimer's disease.
they do suggest that the failure of the brain to keep its house clean
They suggest that the failure of the brain to keep its house clean
by clearing away waste like amyloid beta
by clearing away waste like amyloid beta,
may contribute to the development of conditions like Alzheimer's.
they can contribute to the development of conditions like Alzheimer's disease.
So what this new research tells us then
So what this new research tells us then
is that the one thing that all of you already knew about sleep,
is that the one thing all of you already knew about sleep,
that even Galen understood about sleep,
that even Gail understood about sleep. What?
that it
아니에요.
refreshes and clears the mind,
That it refreshes and clears the mind,
may actually be a big part of what sleep is all about.
may actually be a big part of what sleep is all about.
See, you and I, we go to sleep every single night.
You and I, we go to sleep every single night.
But our brains, they never rest.
But our brains they never let rest.
While our body is still,
Or our body is still,
and our mind is off walking in dreams somewhere.
and our mind is off walking dream somewhere.
The elegant machinery of the brain is quietly hard at work,
The elegant machinery of the brain is quietly hard at work,
cleaning and maintaining this unimaginably complex machine.
cleaning and maintain this imaginary complex machine.
Like our housework, it's a dirty and a thankless job,
Like our housework is a dirty and thankless job,
but it's also important.
but it's also important.
In your house, if you stop cleaning your kitchen
In your house, if you stop cleaning your kitchen
for a month,
for a month,
your home will become completely unlivable very quickly.
your home will become completely unlivable very quickly.
But in the brain, the consequences of falling behind may
But in the brain, the consequence of falling behind
be much greater than the embarrassment of dirty countertops.
may be much greater than the embarrassment of the dirty countertop.
Because when it comes to cleaning the brain,
Because when it comes to cleaning the brain,
it is the very health
it's the very health
and function of the mind and the body that's at stake.
and the function of the mind and the body that's at stake.
Which is why understanding these very basic housekeeping functions of the brain
Which is why understanding this basic housekeeping function of the brain
today may be critical for preventing and treating diseases of the mind tomorrow.
critical for preventing and treating diseases of the mind tomorrow.